Hello viewers, once again welcome to my YouTube channel. In this video I want to solve this lovely integration question. Now in solving this question I need to represent x over e with an alphabet. Let it represent an alphabet x over e to the power of x. Now if I represent z as x over e to the power of x. Now it is very important I know how to differentiate z, because since I represented this with z, I have to change everything to z. I have to write it in terms of z. Now, this can be written as z is equal to x to the power of x, e to the power of negative x, law of indices. What I've done there, x to the power of x, e to the power of x, everything inside takes the power. That's power law. So I want to write this as a multiplier, not as quotient, so I can be able to use product rule. Now in differentiating this, I'm using product with z with respect to x. Now don't forget product rule, the short form is you hold on one, differentiate the second one. The one you're holding on, you use it to multiply the derivative of the second one. What I'm trying to say, I'll hold on x to the power of x, differentiate e to the power of minus x with respect to x. I'll hold on e to the power of negative x and find the derivative of x to the power of x with respect to x. This is what I'm going to do. This is product rule. No need of representing anything with u or representing anything with b. You can hold on one part of it and differentiate the second part of it. Now, moving on, I want to differentiate e to the power of negative x. Derivative of e to the power of negative is minus e to the power of negative x. So I have minus e to the power of negative x multiplied by x to the power of x plus e to the power of minus x. Derivative of x to the power of x. I've done this in one of my videos. Derivative of these, it's straightforward. This gives x to the power of x multiplied by 1 plus ln x. This is derivative of x to the power of x. I cannot start differentiating this. It's a waste of time. Derivative of this is a standard one. This is the derivative of this. So you can go back to one of my videos where I did derivative of x to the power of x. I've also done derivative of x to the power of x to the power of x. Now let's expand this. I have e minus e to the power of x to the power of x, plus e to the power of minus x to the power of x, plus e to the power of minus x to the power of x ln x. I've expanded. Please take note, this is x. Let me write. This is x to the power of x, power of x to the power of x. Now this cancel this, negative and positive of the same number. Now moving on, I have the z with respect to x equal e to the power of minus x to the power of x ln x. Don't forget, this is still the same thing as x to the power of x over e to the power of x, which is the same thing as x over e, everything to the power of x. Don't forget, I represented this with z. So the z with respect to x is equal to z ln x. Now from here, make the x the subject of formula. The x is equal to the z divided by z ln x. So this is what I'm going to put back into the formula given, or the integration question given. This is the z with respect to x. This is what I'm the x. This is the x. This is what I'm substituting back into the question. Is the z over z ln x. So I'll go back to the question. This is a question. Don't forget, let me clean. Let me erase all this. Bing. So it will be easier for me. So I have the x equal the z over z ln x. Now, the integration question, this is already z. Don't forget, I have z squared. I represented x. Don't forget, z is equal to x over e to the power of x. So that's z squared minus z to the power of minus 1. Because this is still the same, this part, the same thing as x over e to the power of minus 1 to power of x. Okay, let me say to the power of x to the power of 1. Power of x to the power of minus 1, law of indices. So z is this, the whole of this is z, so is z to the power of negative 1. Now, so this multiplied by, now this part of it, 1 over log e base x, this same thing as log x base e, law of logarithm. One, if you can change a base, like let's say log a base b, the same thing as 1 over log b base a. So interchanging the base and the log of the function or the number given, change it to a reciprocal of it. So with this, I have this part to be log x base e with respect to x. Don't forget log x base e is same thing as ln x. So this part can be erased and put ln x. And the x part of it is the same thing as the z over z ln x. Ln x cancel ln x. I have integral of z squared minus z negative 1 divided by z with respect to z. We are getting there. So with this, I have this as integral of z squared over z minus z negative 1 over z with respect to z. Here you have z minus z negative 2 with respect to z. So if you divide z squared by z, you're getting z. If you divide z negative 1 by z, law of indices, you're getting z negative 2. Now the next thing is to write them properly and integrate. So let's write properly and integrate. So I have integral of z minus z negative 2 with respect to this z. So if I integrate, I have z squared over 2 minus z negative 1 over minus 1 plus c. This is z squared over 2 plus 1 over z. Or I can say z negative 1 plus c. Now don't forget something is used to represent z at the beginning of the question. I said z is equal to x over e to the power of x. So this will now give us x over e to the power of x squared. Let's say x everything squared plus x over e to the power of x to power of negative 1 plus c. Don't forget I have 1 over 2 here. So 1 over 2 x over e to the power of 2x plus x over e to the power of negative x plus c. Plus c. So this is the derivative of the question given. Thank you for watching and don't forget to subscribe to my channel.